How-to videos. Circular motion, example 2C, speed and acceleration. Valerie is twirling her keychain around. So we say this is the keychain, and it's going around in a lovely circle like this. So here is the velocity, and that means the centripetal acceleration is going to be inward. We know that the radius is 0.35 meters. And what else does it say? Well, it says twirls it 2 times in a second. So 2 twirls per second. That's the number of events per time, which means this is a frequency. So it's important to think about this before we just start plugging stuff in. We've got to figure out if it's a period or frequency. So it is good that we double check this. Period is 1 over frequency, so it's 1 over 2 twirls, and then per second, so that's the seconds up here. So simply put, 0.5 seconds per twirl. If we want to say per twirl on there, that's fine. We don't have to. Okay, now let's go ahead and solve for the velocity. Velocity is equal to 2 pi r divided by t, which is equal to 2 pi times the radius, which is 0.35 meters, all of which divided by 0.5 seconds. That is the period. We tap that into our calculator, and we get 4.398 meters per second. Now, an interesting thing, if we had kept it as a frequency, we could have still solved this problem. We could have said velocity is 2 pi r times the frequency, because frequency and period are related that way. So frequency is just 1 over the period. So that would actually work out just fine if I were to plug in 2 pi times 0.35 times 2 twirls per second. Okay, those are the units there, twirls per second. Anyhow, I plug in, and I would get 4.398 meters per second. So it's lovely either way, but let's just go ahead and say that the final answer for the speed is going to be 4.4 meters per second. Now let's move on to the centripetal acceleration. Acceleration centripetal is equal to v squared divided by r, which is equal to 4 pi squared r divided by t squared. Now you say, why am I going ahead and doing it this way? I'm showing that we can solve it using all sorts of different information. Okay, because I didn't originally have the velocity. I did in fact just solve for the velocity. I assume it's correct, but in case it's not, we can solve it this way. 4 pi squared times 0.35 meters divided by 0.5 seconds. All of this is squared. And we end up with 55.3 meters per second squared. Now, we could have also done this equation. Okay, and it might be a little bit faster, certainly. 4.398. I'm not using the rounded off number. I'm using the whole thing, meters per second. And this whole thing is squared. And we divided that by the radius, which was 0.35 meters. Tap that into our calculator, and once again, we get 55.3 meters per second squared as the acceleration. So either way, it does work lovely.